All right, let's get started. Hi, everyone. Thank you for being here this evening. We're the Stanford Blockchain Club on Stanford campus, and we are a cross-disciplinary student club across engineering, business, and law school for folks who share a passion for cryptocurrency and blockchain technology. Our vision is to be Stanford's thought leaders on blockchain technology, bringing together ideas from across disciplines to create a vibrant community focused on exploring both the technical and non-technical implications of this community. I want to take a minute to thank Charlie and David for being here today to talk about Litecoin's implementation of MimbleWimble Extension Blocks. We are excited to hear from both of you. And I want to say for those interested in being part of the Stanford Blockchain Club, please sign up for our mailing list. And for students who are interested in helping organize events and companies who want to share their work, please feel free to reach out to any one of the club organizers. And with that, I'll hand it off to Nick.
Yeah, and I'll be really brief since I don't think Charlie needs much of an introduction. Everybody knows he made Litecoin, Satoshi Lite we call him. And David is working, he's the lead developer on the MimbleWimble Extension Blocks. And I mean, you know, there's a lot of students in the Stanford Blockchain Club, a lot of very different interests, but I pushed hard for us to make this sort of our big first kickoff event of this year. We had a little bit of a rough transition because of COVID and a bunch of people graduated, but I am just so excited about MimbleWimble and the extension blocks. I mean, this is a huge departure from Bitcoin. I won't steal Charlie and David's thunder, but it's one of the biggest, if not the biggest, project happening on any Bitcoin-based cryptocurrency. Yeah, just excited to learn more about it. So for the people watching on our Twitch stream right now, we have Guy in the Twitch stream, and if you post your questions in the chat, he'll consolidate them, and we'll have some time for Q&A at the end of David's presentation, and he'll ask your questions on your behalf. So I think that's it, and with that, I'll hand it over to Charlie.
Cool, thanks, Nick. So welcome everyone, thanks for coming to our talk. I guess to start off, just want to talk a bit about fungibility and privacy in cryptocurrencies. So in January of last year, I tweeted something saying fungibility is the only property of sound money that is missing from Bitcoin and Litecoin. And now that the scaling debate is behind us, the next battleground will be on fungibility and privacy. And I really believe that. So now I've been focused on trying to make Litecoin more fungible, and hopefully that can help Bitcoin also. I guess first I should probably explain what fungibility is. Any of you may not have even heard of the term fungibility. So fungibility is the idea that for money, it's the idea that each coin or bill that you use is indistinguishable from every other coin or bill. So for example, when you go to a store and you pull out your wallet to spend, to buy coffee, for example, and you pull out a $20 bill, it doesn't matter which $20 bill you pull out of your wallet because it's fungible, right? The store will accept any $20 bill that is genuine, right? That's not counterfeit, obviously. But this is not the case for Bitcoin and Litecoin today. Today, if you, let's say I bought 10 Bitcoins off an exchange yesterday, and I went to a store to spend it, if I use the output of my 10 Bitcoin purchase, the person who receives that coin will actually see that I actually had 10 Bitcoins. So they would know how many coins I have, and potentially even try to figure out, looking in the history, they can try to figure out how many coins I actually have in my account, or they can try to. So there's fungibility is not very good in Bitcoin and Litecoin today. So when thinking about how to make Litecoin more fungible, the first step is to make it more private, because you can't really have fungibility without privacy. If a transaction is not private, then it can be differentiated from other transactions therefore it's not fungible. So focusing on privacy technology, I keep coming back to a technology that's called confidential transaction. So confidential transactions, or CT, was first proposed by Adam Back way back in 2013, if I remember correctly. And it was improved on by Greg Maxwell. And CT basically is a way to blind transaction amounts. So when I send coins to you, the transaction on the blockchain, people can see it, but they can't see how much coins was sent and how many coins were received. So we wanted to soft fork that into Litecoin initially. And turns out that the way to soft fork CT into Litecoin is actually very similar to extension blocks. And extension blocks is similar to a sidechain. It's effectively an attached merge mine sidechain. So every Litecoin block has a corresponding extension block, and miners will basically mine both of them. And then you can move coins between the two, between the main chain and extension blocks. And in the extension block, you can pretty much do whatever you want. So that's the powerful thing about extension blocks. You're not restricted to using like the Bitcoin scripting language. If we just did a soft fork of Litecoin and added stuff, it's very restrictive. But doing it in an extension block way gives us more flexibility. And because of that, we decided to actually look into the MimbleWimble technology. MimbleWimble effectively has confidential transaction, and also has other stuff like cut through that makes it more private, increases privacy, and also makes the chain more scalable. So the idea is we want to add privacy and still keep scalability, which I think is very important. So we explored doing MimbleWimble on Litecoin with extension blocks. And this is where David Burkett came in. David Burkett is the lead developer of Grin++, which is another node implementation of Grin. And he offered to help us work on MWEB, which is what we're calling now. MWEB stands for MimbleWimble Extension Blocks. And I guess I'll let David tell you guys more about the design and implementation. So take it away, David.
Thanks, Charlie, and thanks everyone for having us. Got to figure out how to share here. Did it earlier. Let's see. There. Can you guys see that? Yeah. Okay. All right. So yeah, I'll talk about the design then of the MimbleWimble extension blocks. So I'll first quickly review MimbleWimble. There's a lot of good articles out there that explain it much better than I ever could. So for those of you who really want to dig deep into it, I'll have some links at the end, and a quick Google search will get you quite a bit. But I'm going to talk about the actual design then, of the extension blocks and this integrating transaction, how this works. It's a pretty crucial piece. And then we'll walk through actually transacting via the MWEB to see what that looks like, to see how transactions are created. And then I'll quickly go over the status of the project. So this is just to give a background here on MimbleWimble. They have confidential transactions, which Charlie talked a little bit about. Basically, a typical Bitcoin transaction, you can see the amounts, you can see addresses, you can see, A sends 5 Bitcoin to B, D also sends 1 Bitcoin to B. So some problems with privacy there is obviously the amounts are transparent, but also there's address reuse, which tells me that both these Bitcoins and this Bitcoin here are both owned by B, and he can, when either of those are spent, we know it's the same person. So, confidential transactions on MimbleWimble improve on that because they never reuse addresses. They don't actually have addresses. And then the amounts are hidden. They're just curve points instead. They use Peterson commitments to balance transactions and to obscure the amounts. So all you're doing is just adding elliptic curve points and validating a sum. This is what transactions look like on MimbleWimble. So there's 2 transactions here. We have the top one, which has 2 inputs and 2 outputs, and we have this bottom transaction, which has 2 inputs and 1 output, right? And they also have this extra piece of data. It's labeled as excesses here, but we call this kernels more frequently. These are unprunable. They have like the signature. There's just one signature per transaction instead of one signature per input, so it scales a little better there. But the way it handles inputs and outputs is really cool. So the first thing that we get with MimbleWimble is non-interactive coin joins. So you see that there's clearly 2 transactions here. But anybody who gets these 2 transactions can join them together without knowing anything about them. They don't have to know any of the private keys. If you do a coin join in Bitcoin or Litecoin, you usually have to have some kind of central server or a coordinator or something, but you don't need that with MimbleWimble. You just take 2 transactions, you combine them. And then you can combine them in a way that you can't then separate them. When you receive this, you won't know that there were 2 transactions, or you at least won't know what the original 2 transactions were. But the really cool thing about MimbleWimble here is the thing called cut through that Charlie alluded to. So you have, you see that this first transaction, just go back real quick, creates this output here. And the second transaction actually spends it. The same color just means it's the same output there. What you can do with MimbleWimble is, since it's just a big balance equation of curve points, where you sum up the outputs and you subtract the inputs and do some other things, the outputs in the inputs will just cancel each other out here because it's the same output. So what you can do is you can just delete it, and you can still validate the whole chain without ever having that. So as soon as you spend a coin, you just delete that coin from the history. So MimbleWimble scales actually really well, about 3 times better than Litecoin does today. So it's a pretty cool feature of MimbleWimble, and it's why Charlie and the Litecoin team decided to go with MimbleWimble over just basic confidential transactions. And like I said, there's lots of information on how all this works out there, but that's really all you need to know about MimbleWimble to understand the design we're going to talk about here. So first off, extension blocks, Charlie mentioned, they're just kind of like, they're like a parallel chain here. So this is the main chain, these canonical blocks. This will be your Litecoin blocks here. And each one commits to this second block with a completely different set of rules. It has this integrating transaction where with SegWit, the Coinbase commits to a separate Merkle root for like the witnesses, which is like a separate block of data. And in a similar way, this integrating transaction, which is the last transaction in the block, it'll commit to this whole separate block with a completely different set of consensus rules called the extension block. And so the integrating transaction will just have the hash of this block in it. So then non-upgraded nodes will see this transaction. It'll just look like a normal transaction. They won't know anything about this extension block, but it will still follow the old rules. So it's a soft fork, not a hard fork. But anyone who's upgraded will know that this last transaction has some special rules attached to it, where we also have to validate this whole separate block that it commits to. So it's just a way of adding a bunch of functionality in a backward compatible way. And this is how we do it. And this is going to look kind of complicated here at first, but the general concept here, we have this integrating transaction that kind of that commits to all of the data on the MimbleWimble extension block, the MWEB here. And then you have this whole separate block that has MimbleWimble specific transactions. And we have this way of pegging in coins, which means moving it from the main chain over to the MWEB. And we'll walk through how that works, but you'll see here that this green here, we create this output in a normal Litecoin transaction, but we flag it as a peg in, and then we end up getting those coins over here in this MWEB side. So the header of the MWEB is pretty simple. It has a height, which isn't all that important. It's just it's really not needed at all, but it makes it so that the hash of every MWEB block is unique, even if no new transactions are added. But then it uses these things called Merkle mountain ranges, which are similar to Merkle trees used by Bitcoin today. but it's they allow for if you delete certain parts of the tree, but you have like the parent hashes, so like they have a bunch of leaf hashes all along the bottom of it, but you can remove some of those leaves, and as long as you have the parent hashes, you can still validate that whole tree. And it ends up working really well with the way MimbleWimble prunes outputs, deletes like the old Sven outputs. So we end up using those instead of Merkle roots, and we have one for the kernels, one for the outputs, and one for the range proofs. And those are MimbleWimble specific things that you can read about later. But general idea is there's just these 3 mountain ranges here, similar to Merkle trees, except the big difference is they actually commit to the whole set. So like for Bitcoin blocks, each block has say 100 or maybe 1,000 transactions in it, and the Merkle root will just commit to those 1,000 transactions. But with these, it actually commits to every kernel since the creation of the MWEB, and every transaction output since MimbleWimble was activated. Those are all committed to there, and they're fairly efficient to update, so it's not a big deal. So that's committed to in the header, and that's how we can guarantee when you add transactions to the MWEB that all the transactions are there. You can validate them when you know which transactions are included because of those. And then there's this offset thing, which is just a MimbleWimble specific thing that makes it so after you coin join different transactions together, nobody can separate them. Nobody can brute force them and figure out the original links. So let's look at what happens when we actually peg in coins. So pegging in, like I said, is when you take coins from your main chain and you move them to the extension block. So you can create, first off, the transaction. Your wallet will create a transaction on the MWEB. It has this kernel, and every transaction in MimbleWimble has a kernel of some sort, which has your signature, like I mentioned. And then it just has these outputs and range proofs. These are confidential transactions, or just curve points that are range proof. So you create the transaction over there, and then it has this unique commitment. It's just like a public key in a way. So only you know how to generate this kernel. So then you take this public key then, and you move back to your Litecoin side, and you send coins to that kernel. So you say, I'm going to peg in this example, these 5 Litecoins. And we have this special witness version. Right now, anything other than a 0 and a 1 is an anyone can spend, or anything other than 1 and 2, I can't remember, is an anyone can spend output. So existing nodes, if they see this output, they'll let anyone spend it without any kind of signature or anything. So what we do, we use witness version 9, and we commit to this kernel here in this output. This allows it so you can move these 5 Litecoins to the extension block, but nobody can take those coins from you. You have to actually have this kernel here, which only you can create. So that's just how you move the coins over there and retain ownership. And then there will be a piece that the miner adds too that we'll talk about in a little bit. But this is how you move coins over there. You have your normal Litecoin transaction. You have your 3 Litecoin output. This is your change. You have your pegged in output, which is witness version 9. And then you end up with an equivalent transaction on the MWEB side. I'm ignoring fees throughout this just for simplicity. So then once it's over there, you could transact like a normal MimbleWimble blockchain can. So you can create a bunch of MimbleWimble transactions. They're all prunable, just like in Grin and Beam and all the others. You can, once you spend those outputs, they can be pruned. And the great thing is there's no extra data then needed on the Litecoin blocks. So it scales really well. You can, transact forever there and never grow the main block at all. So you'll want to conduct a bunch of transactions here. The longer they stay there, the more privacy you get from it. And then eventually you may want to move back to the main chain. Most people probably will at some point. So we need to have a way to do that. So we have the opposite of pegging in, which is pegging out. You create a special MWEB transaction that you mark as a peg out. You include your inputs. These are just your MWEB inputs here. So once again, confidential. You don't know, nobody else knows the amounts, only you do. You create this kernel where you say how many coins are being pegged out and which address you want them sent to. So this is your BEC32, your Litecoin address, main chain address. And then of course you can have your change here. We're only pegging out 4, so we get a 1 Litecoin change. And that 1 Litecoin will stay in the MWEB. And then when the miner builds the block, if this transaction is included in the MWEB, then they'll have to send those 4 Litecoins to you. So in that integrating transaction, they create an output for you that sends those 4 Litecoins to your address that you specify here. And all this is verified by other nodes, so the miner can't steal your coins or anything like that. They have to match up. The address that the coins are sent to has to match up with the peg out kernel address here. So then I mentioned the integrating transaction. This is the last transaction in a block. This is something that'll be added once the MWEB goes live. So the last transaction in a block will have these special rules attached to it, where it'll first off point to the previous integrating transaction, and then it will create an output for the new hog address, and this is how we commit to the header. So we have the MimbleWimble header. Let's go back here just a second. So we have this part here, and we can hash it, and we commit to it here. So that's what we're talking about. So we have a special output that commits to the header, and then the amount of that output is the entire amount of the pegged in coins. So you take the previous hog address, the previous integrating transactions amount, you add any peg in inputs that were created. So if someone pegs in 5 Litecoins, you increase the amount by 5 Litecoins, and you include that peg in input. And then any peg outs, you remove that from the amount. So then this first output in the integrating transaction will always tell you exactly how many coins should be in the MWEB. And then the miner has to create those outputs to send any peg outs. So if we go back to this example, we have a peg out kernel where we send 4 Litecoins to this Litecoin address. When the miner mines it, they will include that peg out output here, and this will actually send the 4 Litecoins on the main chain to that Litecoin address. And that's really all there is to extension blocks. You have a concept of pegging in, where you mark your coins as moving to the other side, and we'll have like maturity rules similar to how coin bases can't be spent for 100 blocks or whatever. We'll have similar things there, but you just mark coins as moving into the extension block, and then once they move over there, you have the completely separate rules that are only enforced by new nodes, like upgraded nodes that enforce all MimbleWimble rules. And at some point you can move them back. It's a pretty straightforward concept. There's a lot of nuance involved with developing it, but the general idea is we can just take advantage of these anyone can spend outputs that SegWit created that allow us to that allow the miners to move coins into the actual extension block. And so as far as status, then we launched a testnet at the beginning of the month that right now is just mining blocks, and we could do basic peg ins and peg outs. I have full wallet support now that I just finished up a day or so ago, so we should be testing that over the next few days. But one of the big downfalls of MimbleWimble is once you actually peg in your coins, you have to actually interact with your receiver when you want to send them coins. So for for Bitcoin, if I have your Bitcoin address, I can just send them to you. You don't have to be online. You don't have to, reach out and accept those coins. You don't have to sign anything. I can just send you coins. But for MimbleWimble, there's this complicated process where I start a transaction and then I hand it off to you and you add some information to it and you hand it back and then I got to sign it and broadcast it. And it's a really frustrating part of the protocol. And Lightning Network has similar issues too, where interactivity is required. But we found a few ways that we should be able to add one-sided support with a little bit, with some tweaks to how we validate the MimbleWimble transactions. We can add a little extra data to it and get and achieve a way to have one-sided transactions. So I'm working on implementing that now. And once it's ready, we'll probably relaunch a test net because it'll be sufficiently different to require some additional testing. And then as long as all goes well there, we'll do a bunch of reviews and whoever's going to audit it or whatever. And we should be ready then to merge it into the main test net, activate it on there. And if all goes well, we'll get it activated hopefully sometime in 2021. We have no control over that. Miners have to accept it. Users have to be okay with it. But we're on track right now to have it activated sometime in 2021, which would be pretty cool. So I have some links here to, I think I could maybe send them out somehow. We'll figure it out. But the actual proposals for extension blocks, these are similar to the BIPs. They're just the Litecoin version. This one here explains how extension blocks are implemented in greater detail than what I could go into here, and specifically the MimbleWimble extension block. And if you got a crypto background, I could really use your help here. This is the one-sided transactions proposal. It's a work in progress right now. There's some minor tweaks I need to make, but it hasn't had nearly enough eyes on it. So I'd love for some crypto people to have a look at it, see if they can break it. So if you know crypto, I'd appreciate the help. And then this here's the original MimbleWimble white paper, you could call it. It was just anonymously dropped with an onion link in an IRC chat a few years back. But it goes over the general concepts. But if you really want, if you have a good understanding of Bitcoin, this is probably your best explainer here. This is the Grin intro doc, and it takes you from an understanding of Bitcoin all the way up to a thorough understanding of MimbleWimble, why range proofs are used, what kernels do, how offsets come into play, and all that. So this would, if you really want to understand MimbleWimble, this is a good place to start here. And if you want to help out with coding, we have the actual MWEB code base listed here. So pick up an issue and submit a pull request. We'd love to have your help. I think we have a Q&A session now, right? How does that work?
Yeah, if people have questions, feel free to raise your hand on Zoom or post it in the chat as well, and we can call on you. I think, Guy, if I'm not wrong, there's a question on the Twitch live stream.
No. I think the question is a joke.
And I use that.
Yeah, I have a question. Yeah, my question is, what are the trade-offs with MimbleWimble block sizes? Because at the risk of sounding like Roger Ver, I think that we should just have the biggest blocks we can to get more transactions in and get a bigger anonymity set.
Yeah, we don't know exactly what block sizes we're going to go with. The good thing is with MimbleWimble transactions is most of the transaction is prunable. So you don't have the problem where you have years and years and years of data just accumulating. It doesn't really scale linearly with number of outputs. It's just with number of transactions. So the state doesn't grow as fast, making the initial block download a lot faster. And I know that's like Luke Jr. He's the one who's like real crazy, wants to like move the block size to like 200K or something. But like his big concern is always with the massive amounts of data that accumulate over time. But MimbleWimble doesn't have that problem, so you know, it definitely has a lot of a flexibility there to grow. But the transactions themselves are kind of big because they have range proofs involved. So, you know, we'll have to have at least a decent block size to fit a large number of transactions in there. But yeah, the bigger the block, though, the more processing power for a live running node in order to validate them, because they have to validate bullet proofs, which are much more efficient than any existing range proof we've had, but it's more than just a simple signature. And then there's each kernel has a Schnorr signature, which everything's batch verifiable, but that doesn't mean necessarily it's fast. So there's a lot to think about. We have to do a lot of benchmarking to see what seems to make the most sense given the hardware that most nodes are running, and you know, how large of a chain state we're willing to deal with. So that's not really an answer. I just talked. But, yeah.
Yeah, that's like a research prompt.
Yes.
Well, basically, we haven't thought too much about it. I mean, the good thing about MimbleWimble Extension Block is that we're doing it in an extension block is we can increase the block size to whatever we want, actually. So obviously we want to pick something that's not crazy. We don't want to make it so that people can spam with transactions and cause the blocks to be huge and decrease decentralization. We can also keep the block size the same, right? We can have a way so that enforced by code where the combined two chains, right? The extension block and the canonical chain still is 1 megabyte per block, or sorry, but with block weight, it's like around 4. But we haven't decided yet. We just need more research and more time to think about it.
And the one-sided transactions proposal too, there's a couple different ways we could go about it. So depending how we do it, will affect throughput too, which will come into play when deciding how large of a block we need.
I had a question, if I can jump in. I'm very curious about the non-interactive MimbleWimble transactions. I'm relatively familiar with the original MimbleWimble, and that was always a bottleneck that, if you've solved, is fantastic.
Yeah, solved mostly. So there's an issue if you're able to force a large reorg, like 2-week-long reorg. You can take back coins that you sent to someone that were never sent. So like if I send you coins and then a month later you still haven't spent them, and I'm able to mine, rewind the chain 2 weeks and mine a separate chain, I can take those back without going the full month or the full year back. So it's a minor security trade-off, but it's not a practical one because it has to be a full 2 weeks. It's not like one day will get you anything. We have this concept of a horizon where we never prune beyond the horizon, or never prune past the horizon. So like the past 2 weeks, we have all of the outputs there. So we can verify things like we can attach an address to these outputs. We can verify some additional signatures. So it sort of looks like a Bitcoin transaction. But then, yeah, like if someone's able to reorg 2 weeks or something, they can skip that part of the verification, which would allow them to spend it themselves. But it's only coins they've sent in the past. It's not like they can take any arbitrary coin. And yeah, it's not a practical problem, but the purists will say, oh, it's still an unsolved problem. But from a practical perspective, it's very solvable. And yeah, like I can send that link in the chat for the actual proposal out there. It's just a PR right now.
Yeah, that's great. Thank you. That does seem like a very reasonable, practical trade-off, given you have the a much smaller synchrony assumption for things like atomic swaps, and no one ever
Right.
no one
yeah.
makes
No
much
one bats an
like
eye about that. Yeah, exactly.
And we'll post all of the links in the YouTube description.
Okay, cool.
Once we
Yeah,
upload it.
There's a very technical question in the chat for David. This is about Merkle ranges and Merkle trees.
okay.
The question is, can Merkle monkeys swing from one Merkle branch to another, or do they need prune first?
Yeah, I mean, I think it would be easier to do if you haven't pruned, because you'll have more branches to hold on to. Once you start pruning, then you've really got to leap a long distance. So I'd say without pruning, it's actually easier. Yeah.
That's probably true.
Yeah, because if you try to leap through a prune branches there, it's like having a very sparse forests where you have to like,
Then the monkey will fall
Seems
down
dangerous.
and no one will be,
Yeah.
no one will have any fun. So
yeah, it just seems dangerous. Yeah.
If I can ask a maybe slightly more serious question.
Oh, were we not serious there?
This upgrade, this change to MimbleWimble is one of the more significant changes to a live popular blockchain running in production. And I'd be really curious to hear about your experience kind of forming consensus in the community, and also about some of the technical changes trying to interoperate with the existing Litecoin chain. If you can maybe describe your experience there a little bit.
Yeah, so first part was about consensus. So we're gonna, I mean, we haven't activated yet, so we don't know what kind of challenges we're gonna run into, but we're gonna have BIP 9, which has like, Charlie could probably talk more about it, but as far as I know, miners can signal for it, and as long as they signal enough blocks signal for it in a certain window, then it can go live. But if none signal for it, I think it expires after a year, or maybe it automatically does it. Charlie, can you speak for that? If they don't signal within the first year, does it expire? Is that, and then like it doesn't go live, or does it just automatically go live at that point?
sorry, I got disconnected. What was the question again?
For BIP 9 activation, if miners don't signal within that first year, does it expire? It doesn't activate then?
Yeah, it expires. So
Okay.
I mean, we haven't decided how we're going to activate this. We're likely going to do with something like BIP 8, where basically you have like a certain amount of time, maybe like a year, for miners to activate. If they don't, then it will automatically activate at the end of the year. So the miner activation just gives them the ability, if they're ready, to do it sooner. But then there's a kind of a block cutoff period where it will just activate automatically after a certain amount of time.
So if for some reason, like only 40% upgrade or something, we'll be in trouble there. But I think we'll see that coming from a distance away. And
Yeah,
handle
yeah. So I mean, the idea is we want to make sure that this is, I mean, we've already made sure that this is what the community wants, right? So people want this. There's consensus is people want this on Litecoin. So we don't want to make it too political and make it so that miners can block it like they did, or they tried to do with SegWit. So I guess we'll see. We still have to figure this out.
And then, yeah, sorry, the second part of your question then, Guy, I forget, what was that?
About helping MimbleWimble conform with some of the existing technical constraints of Litecoin, as opposed to the other limitations here.
Yeah, so the only big constraint here is we have to peg in. So it's not like, sort of like how payment channels, you have to fund them first. And it's a change, it's mostly a UX change. It's not so much a technical one. Like my presentation was specifically about the actual technical challenges for pegging in and pegging out. And they're really not that extreme. I mean, there's a lot of code, there's a lot of, different scenarios you have to think about, but the general idea is pretty straightforward. You know, you just mark these coins as going in there, and you have minor enforced rules that move those coins there. But yeah, I think the real challenge is going to be in the UX side, getting users used to pegging in, understanding. You'll have two different addresses now, right? You won't just have your T Litecoin, you'll also have your MW Litecoin or whatever we do with it. And people need to understand you can't send T Litecoin directly to someone else's MimbleWimble Litecoin. And wallets will deal with that, but it's really going to be a UX hurdle. I think that's a bigger challenge than the actual technical problems involved.
Wonderful. We had a question from Luis on Twitch. He asks, how has the Bitcoin community reacted so far to MimbleWimble? Is it something they will look to implement like SegWit, or will this be unique to Litecoin?
So this, I mean, this is a pretty drastic change, right? So Bitcoin, I think it's going to be more conservative. I don't see Bitcoin implementing something like this anytime soon. But you never know, right? If it works really well on Litecoin, it may happen. But I don't expect that to happen. I think a lot of people in the Bitcoin community are like big fans of MimbleWimble. But they just don't know how that would actually work with Bitcoin because it's so different, right? MimbleWimble and how Bitcoin works right now. So I guess extension block is actually a very cool way to add MimbleWimble to a Bitcoin-based blockchain. That's what we're trying to do. So I guess we'll see.
Yeah, a big problem some of the Bitcoin community has with it is that 21 million is like gospel at this point. And, you know, MimbleWimble doesn't change that supply. But the fact that you can't just look and see, you know, every single coin, and you can't just add them up with pencil and paper, it's a concerning thing to them. Auditability is crucial. You saw how big of a deal it was with Ethereum not knowing, you know, their exact supply down to the, you know, exact number of ETH is plus or minus a % or two. And yeah, you saw how people reacted there. They have similar concerns about any privacy technology. And it's just a subset of people. There's a lot that want privacy. I know the Blockstream devs there, they love the idea. There's some tweaks they'd make to make sure it's more quantum resistant. But overall, I think a lot of the technical community loves the idea, the people who actually understand how MimbleWimble works. But there's just this great fear that there's going to be some kind of inflation bug, and you know, the 21 million gold bugs or Bitcoin bugs or whatever you want to call them are not willing to take that risk yet. So it's definitely a bigger battle to get something like this to Bitcoin.
Yeah, there's definitely it's definitely very different. There's definitely a risk of hidden inflation. There's always that kind of risk when things aren't transparent. Mm-hmm. And one of the cool things about the way we're doing with extension blocks is you can actually see all the coins that are on the MWEB side of things in this one address, the hog address, the hog adder. So like block explorers will actually probably very likely highlight how many coins are actually moving to the MimbleWimble extension block. And any risk, any thing that happens, if, for example, there is an inflation bug, it will only affect coins in the MWEB, right? So yes, there's definitely some risk, but if there is a hidden inflation, you'll see everyone try to move coins out, but then you can't move more than what's actually moved in. So if it really fails, then the extension block will fail, and I guess we'll start over and try something different.
But the Litecoin will stay intact. The main chain will be fine. It will be limited to 84 million, right? Yeah. Yep. Forever. Yep.
Unless, of course, I decide to print more.
Well, yeah. Consensus is through Charlie only. So.
I think we have another question from Nick Mamela. How would you define success after implementation?
Usage.
If it doesn't crash and burn, it's pretty successful already. But yeah, like David said, usage. we'd like to see more people use it. And yeah, just like with any privacy tech, more people using it creates a bigger anonymity set, and that helps with privacy and fungibility. Yeah.
Yeah, you see with Zcash where there's a lot of Z address usage. It's getting a little better now, but a lot of people would just go from T address to Z address and then right back. I expect that to be the case with the MWEB at first too, which doesn't really get you those privacy gains where, you know, if you just peg in, make a transaction and peg back out, you could still follow those coins pretty easily and see the amounts. But I longer term, if we could start to get exchanges and services, businesses to accept MWEB Litecoin as you know, at face value, the same way they accept typical Litecoin, that'll be real success there. That'll be where you really see the anonymity set grow.
Yeah, and one of the challenges we have is that it's a different kind of, the extension block is different, so that such that wallets have to support it, right? So initially, the nice thing about a soft fork is nobody has to change anything. It will just work. So wallets will just still work on the main chain. They won't even have to know about the extension block. But the downside is if they don't support it, then no one can actually use it, right? So starting off, we will add it to like Litecoin Core, maybe Light Wallet will support it. And it's not simple, right? It's kind of a bit of work to actually add support for the MWEB to an existing wallet. So I think adoption will be slow because of that. But so we'll hopefully we'll try to get things moving and try to get more adoption.
So this might be a little bit premature, but have exchanges and already asked you about the legal implications? I mean, you're kind of a Trojan horse turning a transparent chain into a privacy coin.
Yeah, I've actually, before I kind of decided to go on this path, I reached out to exchanges just to make sure they're okay with this idea, right? So most of them, pretty much all the exchanges I've talked to most of the major ones, they're okay with, they don't think it's an issue in terms of like the regulation side of things. Like they're not going to delist Litecoin just because we added this. This MWEB is an optional thing, right? So it's, exchanges don't actually, I don't see exchanges supporting the MWEB side of thing anytime soon, and they don't need to. They can just support the main chain. And if you want to sell your coins on that's in the MWEB, you just peg it out and then send it to an exchange, and it'll just work just like today. And exchanges have told me they don't think this is a concern in terms of regulation. So that's good news, but it's not 100%. Like we don't know for sure, right? Maybe after we launch it, some exchanges might have issues with it.
We've seen Gemini added Z address support recently for Zcash. There's been a few others that have added it. So yeah, there is hope that at least some will try to support it in the long term. Yeah.
We had another question in Twitch. Will the price of Litecoins always be the same as price of MWEB coins?
I mean, the market can value them differently, but you can always peg them out to, you know, to get the original Litecoins. So it's kind of like how two different exchanges, due to different liquidity issues, may have a slightly varying value of Litecoin. It's possible a market like that could develop just because of the extra time and transaction fees of moving from Litecoin to MWEB or back. But in general, you're dealing with roughly the same thing. It's kind of like, you know, it's like wrapped Bitcoin or something like that. It's the same thing. It's possible there could be minor fluctuations, but I would never expect it to be anything significant.
Yeah,
and hopefully we can get a lot of adoption. So yeah.
You can easily peg in and out. So it's even simpler than a lot of the wrapped Bitcoins solutions or even Tether. Sure. So yeah, so maybe some exchanges might have like a MWEB coin, but I don't see that being the case. I think one Litecoin on the main chain is basically one Litecoin on the extension block. The only thing that would cause a price to really start kind of separating is if there is a inflation bug in the extension block and everyone is trying to get out of it, right? Then the price will kind of tank on the extension block side of things. But we don't expect that to happen, right, David?
Yeah, well, that shouldn't be a problem. So, yeah, and you can even you can peg out to an exchange. You don't have to peg out to yourself. You can, if you have an MWEB coin, you don't have to have that separate step. You can just peg out directly to an exchange. So there really shouldn't be. What's that?
Or to anyone else.
Or to anyone else, yes,
Yeah.
to anyone. You don't have to go through yourself first. Pegging's a little bit different. Yeah, I mean, you technically can still peg into someone else's thing, but that's a more complicated interactive flow. But for pegging out, you could definitely just send anyone your MWEB coins on the main chain.
Well, it looks like we don't have any more questions, and we're just sort of running up on the initial time. So I just want to thank you guys again for speaking to us, and this has been really interesting.
Yeah.
I guess the last call for questions.
It's been a lot of fun. Thanks for having us.
Yeah, thank you very much.
It's definitely very different from the last time I was at a Stanford blockchain meetup.
Yeah. For those who don't remember, the last time Charlie was here was 2017 at the I guess I want to say November 2017 in the peak of the bubble.
Yep.
And it was like 400
crazy.
people, standing room only. Wouldn't happen again with COVID.
I think that's the end of our session for tonight. If you guys have any other questions, please feel free to send us an email. Also join our Discord channel. We will put all of the information and send it to you in the email as well as on the YouTube video. Thank you. Thank you all for coming, and thank you, Charlie and David.
Thank you.
Thank you.
Take care,
Thank you,
guys.
guys.